like to welcome you to this live discussion on Schizophrenia Research Forum on synchronized neural oscillations in the pathophysiology of schizophrenia. Neural oscillations and their synchronization may represent a versatile signal to realize flexible communication within and between cortical areas. By now, there is extensive evidence to suggest that cognitive functions, depending on coordination of distributed neural responses, are associated with synchronized oscillatory activity in the theta, alpha, beta, and gamma band, suggesting a functional mechanism of neural oscillations in cortical networks. In addition to its during normal brain functioning, there's emerging evidence that neural oscillations may be altered in major neuropsychiatric disorders such as schizophrenia. Already, there is good evidence on the alterations in high-frequency oscillations in schizophrenia, as well as preliminary evidence for impairments in theta and alpha band activity. Accordingly, altered neural synchrony may represent the functional correlate of disconnectivity in cortical networks in schizophrenia and underlie the characteristic fragmentation of mind and behavior. Impaired neural synchrony may also be linked directly to altered neurotransmitter systems in schizophrenia, as much is already known about the underlying systems involved in the generation of oscillations and resynchronizations. In addition, manipulation of neurotransmitter systems in vitro experiments, for example, allow the direct test of the involvement of specific receptor systems in the generation of abnormal rhythmic activity that provide critical tests for the pathophysiological mechanism in schizophrenia. In the live discussion on Schizophrenia Research Forum, we would like to address a number of questions that we consider critical for research on synchronized neural oscillations in schizophrenia. Specifically, we would like to look at the question to what extent specific frequency bands are affected in schizophrenia. For example, is it specific to the gamma band, or also do we find involvement of other frequency bands in the disorder? To what extent does it reflect a generalized impairment across different cortical areas, for example, or to what extent is it specific to any cortical site? Moreover, an important question is also the diagnostic specificity of impaired neural synchrony in schizophrenia. An important point are also the methods that have been used to examine neural oscillations and their synchronization in schizophrenia. Therefore, it is important to raise the issue to what extent there are specific methods that have yielded the best results. And a related question is to what extent we need standardization of methods in future research. An important question already alluded to are the possible mechanisms underlying impaired neural synchrony in schizophrenia. And finally, an important question is also to what extent neural synchrony can account for the neurodevelopmental profile of the disorder. Any supposed pathophysiological mechanism in schizophrenia has to address the neurodevelopmental profile of the disorder. There is important evidence that suggests that neural synchrony, in addition to accounting for the impairments in cognition and also associated symptoms, may be related or involved in the developmental profile of schizophrenia. On a general note, we know that the development and maturation of cortical networks critically depend on neural activity, whereby synchronized oscillatory activity plays an important role in the stabilization and pruning of connections, for example. We know that during early development, especially during the prenatal and early postnatal periods, the cerebral cortex exhibits self-generated synchronized oscillatory activity that is believed, for example, to be essential for the shaping of cortical circuits. Therefore, a malfunctioning during this very early period might be already laying the ground for later impairments in schizophrenia that critically emerge during the adolescent period. In addition to the important role of neural oscillations in the shaping of early cortical circuits, there is emerging evidence that neural oscillations undergo also substantial changes during normal adolescent development. For example, there is recent research that has shown that the auditory steady state response, specifically in the gamma band, increases during adolescence, and also work by our group has suggested that there are major changes in the synchronization of neural oscillations in both the theta and gamma band. Therefore, we can assume the following hypotheses: that early pre- or postnatal developmental errors initiate a vicious circle that jeopardize the self-organizing developmental processes required for the expression of normal connectivity patterns. Here we believe neural synchronization might be an important mechanism. However, it is probably difficult to say to what extent it is causally related. It is probable that neural synchrony might be a cause as well as an effect of any neurodevelopmental trajectory that is malfunctioning in schizophrenia.